Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today. For exam P on probability, let N1 and N2 represent the numbers of claims submitted to a life insurance company in April and May, respectively. The joint probability function of N1 and N2 is 3/4 times 1/4 to the power N1 minus 1 times e to the minus N1 times 1 minus e to the minus N1 times N2 minus 1, for N1 equal to 1, 2, 3, and so on, and N2 equal to 1, 2, 3, and so on, and 0 otherwise. Calculate the expected number of claims that will be submitted to the company in May if exactly 2 claims were submitted in April. And here's a solution. We begin by finding the conditional probability function of N2 given N1 equal to N1. So f sub N2 of N2 given that N1 is equal to N1, which is the joint probability function f N1 N2 of N1 N2 divided by the marginal probability function f sub N1 of N1. Okay, f sub N1 of N1 is the sum of over all values of N2 from 1 to plus infinity of the joint probability function. We have a common factor in all of them which does not depend on N2, so we put it in front. That's 3/4 times 1/4 to the power N1 minus 1. And then we have the sum from n equal 1 to plus infinity of e to the minus N1 times 1 minus e to the minus N1 to the power N2 minus 1. This is actually a sum of a geometric series with ratio 1 minus e to the minus N1 and first term e to the minus N1, which is equal to e to the minus N1 over 1 minus e to the minus N1. Well, look at that. That's actually e to the minus N1 over e to the minus N1, so it cancels out. And what we get is 3/4 times 1/4 to the power N1 minus 1. That's the marginal probability function of N1. Therefore, f sub N2 of N2, given that N1 is equal to N1, which is the joint probability function divided by the marginal of N1, well, we divide them, and what we get is e to the minus N1 times 1 minus e to the minus N1 to the power N2 minus 1. This is actually the probability function of a geometric random variable with parameter p, the probability of success, of e to the minus N1. When you model a geometric random variable as a repeated Bernoulli trial with a certain probability of success, which we denote by p. The mean of this distribution is 1 over p, which is 1 over e to the minus N1, so it's e to the N1. And that equals e squared when N1 is 2. And that's answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.